In 2018, Google DeepMind's AlphaZero shocked the chess world by defeating the world's strongest chess engine, Stockfish. Now, 7 years later, as part of the Leela Chess Zero development team, I'm excited to show you how far we've come since then, developing the ideas introduced by AlphaZero into a chess entity over an order of magnitude faster and more intelligent than the version that defeated Stockfish. AlphaZero was a revolutionary breakthrough in artificial intelligence, using reinforcement learning to teach a neural network how to play chess from scratch, then evaluating that neural network tens of millions of times to search through the game tree. Its play showed breathtaking creativity and ingenuity, bringing new ideas into the game that hadn't been seen from humans or engines alike. But what if I told you that AlphaZero left a mountain of opportunity untapped? While its approach was groundbreaking, it was limited by the methodologies of its time. Since then, the field of AI has evolved rapidly, and we've brought new ideas from the bleeding edge of AI into Leela to take AlphaZero's foundation to new heights. The first area we looked into was the neural network the engine uses to guide search. AlphaZero used a convolutional neural network, which analyzes a position by having each square look repeatedly at what's happening at adjacent squares. But while convolution-based models are effective at capturing local patterns, they struggle with the kind of long-range interactions that underpin the game of chess. To take chess-playing neural networks to the next level, we turn to the transformer architecture, which today is powering large language models like OpenAI's ChatGPT. At the core of the transformer is its self-attention mechanism, which models language by letting every word in a text attend to every other word, selectively incorporating relevant information into its representation. We adopted this architecture for chess by treating the 64 squares of the chessboard as words that interact with each other based on the current board state. We refined this approach by developing a custom position encoding called smallgen, which enables the model to interpolate between a set of learnable attention maps which mimic the kinds of patterns seen in chess. Smallgen effectively doubles the model's representational capacity, allowing it to analyze positions with far more depth and accuracy than before. With smallgen, we've observed attention heads specializing in diagonal, vertical, and L-shaped movements, following the kinds of piece movement seen in chess. Even more impressively, some attention heads have learned entirely from scratch to identify which pieces can move to each square. This breakthrough brings us one step closer to a neural network that truly understands chess at a fundamental level. But how do these models fare against AlphaZero? Our fourth generation of models is over 700 ELO stronger than the model used by AlphaZero, winning over 99% of the games we play between them. These models are strong enough to beat Grandmasters without searching through the game tree, just taking the neural network's raw move prediction. And they're so efficient that they generate these Grandmaster level evaluations 20 times faster than it takes large language models like ChatGPT to generate a single word. But now that we've talked about what our models can do without search, let's look at what they can do when we push them to the limit on modern hardware. On a consumer-grade RTX 4090, Leela Chess Zero can evaluate 5,000 positions per second, effectively emulating the evaluation strength of 15,000 Grandmasters. On our strongest testing machine with 8 RTX 4090s, Leela can evaluate 40,000 positions per second, effectively mimicking the strength of 120,000 Grandmasters, all working in real time to analyze a position. And with the search improvements we've made over the past few years, these Grandmasters can now reuse evaluations to save on compute, express uncertainty about their evaluations to focus more on uncertain positions, and combine positions that are reached multiple times, consolidating the search tree into a search digraph that's vastly more memory and compute efficient. In a 1,000 game match between Leela and AlphaZero, Leela wins 18 times more games than it loses. Even when we give AlphaZero 20 times longer to think, Leela still wins more than twice as many games as it loses. So how does an engine with 20 times the strength of AlphaZero play? I'll let Magnus Carlsen, the highest rated player of all time, explain.
Leela Zero, that's sort of the clone of AlphaZero because they discontinued that. It will also do things that just confounds the very best chess engines in the world still.
Our new and improved Leela displays unparalleled intuition and game understanding, seeing inhuman tactics and ideas that today's top engines like Stockfish miss completely. Courtesy of Gothamchess, Here's one position from the chess.com Computer Chess Championship, showcasing the kind of stuff Leela can pull off. In this position, Leela is playing as black against the top Stockfish engine, and Stockfish just has to move the bishop to give checkmate. There is only one way to save the game. If you don't see it, that's okay, because Stockfish couldn't see it either, despite searching through hundreds of millions of positions. I'll let Gothamchess tell you what Leela finds here.
Because in this position, Leela uncorks a 4-punch combination sent from the gods themselves. Bishop G2 check. You have to take this with the rook, because if you take it with the king, I take the rook and then it's check, and then you get mated.
Leela then proceeds to sacrifice every single one of her pieces against Stockfish in a forced stalemating line, leaving her without any moves to force the game into a draw.
And now the final touch, queen to F2 check, completely forcing you to take the queen, and the game ends in a stalemate, and Leela saves the day.
The most fascinating part of all of this is that the neural network didn't just stumble upon this idea by accident. It actively planned the whole thing out. In the original position, the bishop check is the network's second most highly ranked move, and once the bishop is taken, the network, despite being 8 points down on material and 1 move away from being checkmated, already understands that the game is a draw and correctly predicts every other move in the sequence. And that's just the beginning of what our neural network and enhanced search algorithm can accomplish together. This powerful combination can design unique defensive structures that its toughest opponents don't understand, and can even win games from losing positions by detecting positional ideas that trap pieces that top engines miss completely. Having an engine that's not only strong, but also one of a kind in terms of playstyle is great, not just for beating other engines, but also for informing the way we humans understand the game. Here's Carlsen again on why having such a strong neural network-based engine like Leela is so useful.
And like all the best coaches and players now when you work with chess computers, like you always have both like a neural net and a traditional chess engine.
And here's 5-time US champion Hikaru Nakamura.
There is no discussion. AlphaZero and Leela are the best chess players on this planet and in this galaxy as far as we know. So because of that, when computers say play h4, we listen to computers and we try to play like computers.
Leela has come a long way since it was originally developed in 2018, from replicating AlphaZero's success to far surpassing it. But we still have a long way to go. Our 5th generation architecture will provide an 8% speedup of the last one, and early experiments suggest that quantizing the matrix multiplications in our models could provide another 50% speedup to the engine. As always, the Leela Chess Zero project is open source, and is constantly being iterated on by members of the community. If you have an idea you want to contribute to the project, I've put a link to the developer Discord in the video description. And make sure to subscribe for more updates as we continue to push forward the state of the art in computer chess.